Director of Interdisciplinary Arts Programs at Stanford, and host of Art And, where we explore how artists and scientists are shaping new ways of seeing the world. Today, we're talking with artist Camille Utterback and astrophysicist Risa Wechsler, two Stanford faculty members whose work connects data and the cosmos. Fathom is a new interactive public artwork suspended within Stanford's Computing and Data Science building, which was created by Camille. It turns visual artifacts and computational research into a compelling work of art that can be felt. Their partnership is continuing to expand through a Humanities Seed Grant, using live astronomical data and AI to make huge concepts a little more accessible on a human scale. Here's our conversation with Camille and Risa. So thank you both for being here. I want to start with Risa. I know that you've collaborated with artists in several formats on campus. What draws you to artistic partnerships?
I really enjoy exploring my work in new ways and the work of my colleagues in new ways. You know, the questions that I think about every day, questions like, what is the universe made of? How did we get here? How did everything in the universe form? I think they feel very sometimes abstract and, distant from people, but I actually think that most humans are interested in these questions. And I think that artists have a different perspective on sort of the wonder that we have in both these questions and in the data and theoretical tools that we have to answer them. And so I really enjoy those kinds of collaborations to bring those different perspectives out and to also bring the work we do to broader audiences in new ways.
So let's talk about Fathom. How did your collaboration begin? And what were some of the early conversations that signaled that there was something to build together?
I was trying to think back about this before this interview. I had included an image of dark matter for one of the triangles in the early renderings, like even in the proposal phase of Fathom, because I was interested in thinking about data at different scales and like what images would be compelling to people to like access those ideas. But I think I even knew about the dark matter imagery because I already knew Risa and had been to some talks she'd given more for the general public, like at the Academy of Sciences. I saw the some renderings that she and her colleagues had done, even I think before we knew each other at the Academy of Sciences, but I knew like, oh, that's someone at Stanford. So I think my awareness of dark matter had to do, with being colleagues with Risa. But I think I was explaining the proposal to Risa and she saw this like web image of dark matter that I had pulled and was like, you're not going to use that, are you? Like, you're going to could you use some of my imagery, my simulations, like based on the data we're collecting? And I was like, oh my God, I would love to do that. I didn't know sort of if that was possible. So it started there. And then I met a bunch of times with Ralph and Risa and looked through the different kind of simulations that they had already built. I think in the end, Ralph rendered some different ones for me. It's hard to figure out, from these really dense, like gorgeous 3D animations, everything is moving in relation to each other. So like what moment makes sense for my first project was figuring out the layers of the glass. So the pieces in Fathom, each panel, there are 5 triangular panels. Each one has a glass layer, custom glass layer, and a projected layer. So I was initially just trying to figure out what imagery would be in the glass. And then, so we worked with a very specific rendering from that Risa and Ralph helped me with from their data. And then we used a bunch more simulations that were animations that were moving in the projected layer. Because we were friends and Risa saw the original proposal and was horrified at the bad image of dark matter that I had pulled for the proposal.
So you were describing the way that you created the different triangles. For those people who haven't seen it, can you describe a little bit more about what Fathom is physically and experientially?
Yeah, so the CoDa stairwell is this giant red stairwell, and the spec for the artwork was to think about and engage with people as they were moving through that space, and how to connect again the conceptually what people might be working with regarding data in that building. So I knew I wanted to create something at all levels of the building as much as I could, and then the content I was interested in were the various historic ways that humans have worked with data, right? So we think of it now as this abstract computational thing, but that it is still in the form of our, the minerals that are in our computers, right? Or the magnetic and electronic signals. But at different times, people used fiber, etchings, all these different ways of thinking through data. So I wanted to bring that visual material history forward. So each panel has a theme that is visualized in a glass layer. There's colored glass and etched glass. So the panels work like stained glass in the day when the sun is streaming through. And then there's a dynamic layer of projections on all the panels that are activated at night. Which is how Risa and I are going to continue collaborating, pulling from live data streams for some of those visualizations. And 4 of the 5 panels also have camera interaction. So that's something I've done for many, many years in my work. And I think it's a really effective way to get people to think about their relationship with something that's pictured. So I really wanted people to think about their own physical relationship with all kinds of data, whether it's a map or these ideas of the cosmos, or the patterns that are in our fabric still, like how do we encounter data in our bodies?
Yeah, it's really interesting thinking about translating that into visual and interactive forms, and so perfect in the new CoDa building. In this building, Risa, you are establishing the Center for Decoding the Universe. That sounds like a pretty big job.
Yeah,
tell me more. Tell me more about the research goals of this center.
I spoke to some freshman potential physics majors yesterday, and I told them that I work on modeling and mapping the entire universe. It's which is partially true. We haven't done the whole thing yet, but we're doing the best we can. I think we're at this really, really exciting time in astronomical data where we've actually been a data-rich field for, a few decades, really sort of swimming in lots of exciting data, but that is about to explode, as actually it is in many fields, but certainly that's true in astronomy. And so I'm personally very excited about thinking about how do we use all of the modern tools we have available to us, data science, AI, statistics, computer science, to really make the most of these complex data sets. And we here at Stanford and SLAC have been leaders in a project called the Rubin Observatory's Legacy Survey of Space and Time. We built the biggest digital camera ever built, and that camera is now been shipped to a telescope in Chile. It's actually going to start its 10-year survey before the end of the year. And that particular instrument is going to be taking about 20 terabytes of data every night for 10 years. And then we will add to that data from all kinds of other sources, space telescopes, ground-based spectrographs, things at higher resolution. And so it's just really a very exciting time. And so the Center for Decoding the Universe is really, it's a partnership between CAIPAC, the Astrophysics Institute that I lead, and Stanford Data Science. It's been really exciting to really try to build interdisciplinary collaborations to think about these data. We're really thinking that we can learn from other fields of science and methodology experts, as well as, our data has hard challenges that people in other fields find interesting. So it's great to be engaged in that building. And it's so exciting, actually, to have this sort of visual piece that Camille created. Right there, we had our first meeting, a few months ago, and it was just wonderful for people to sort of be able to see that in the space. And that really was, we didn't know center was going to happen when Camille put the proposal in. There were really sort of independent things that happened at the same time, and it's been really wonderful and synergistic.
It's amazing that everything aligned just at the right time. And this telescope sounds amazing. How many pixels are in the sensor of the camera?
Yeah, it's 3.2 gigapixels. So it's very large. You would need about 1,500 Ultra HD TVs to view just one image, and we take one of those every 30 seconds.
That's crazy.
So, and it's a big field of view. So it's about 45 times the size of the full moon. And we take about 1,000 of those every night. And so we can survey the entire southern sky in a few nights. And then we will basically not only be making a movie, an image, we'll also be making a movie with like 825 images of every part of the sky over 10 years. So one of the things that Camille and I are talking about for the next phase of this piece, as she said, she's very interested in sort of movement in this space and sort of thinking about how data changes over time and how we can visualize things. One of the exciting things about this survey is that every single night, we're going to be looking at everything in the night sky that changed. And we're expecting between 1 and 10 million things to change. So that's everything from asteroids that are nearby to supernova that are 13 billion light years away to stars that are moving in the Milky Way and everything in between. And so we've been thinking about interesting ways to visualize the common things and the rare things and the things we've never seen before. So we're just at the start of that conversation, but that data is going to start coming at us in just a few months.
That's amazing. So, Camille, how are you thinking about translating all of this data, and how does that work? How is it then connected to this piece?
It's actually a huge challenge because even just hearing Risa explain again the magnitude of the information, like my projections are not even HD. So there's not even enough pixels in any of these projections to even begin to remotely absorb the complexity of that data. But I think that's a really interesting challenge and something as an artist I'm really fascinated about. Like humans perceive things like movement or edges, like, or color temperature, like all of those things. And we can also perceive a lot of different things at once. So I think the challenge Risa and I have been talking about, or I know the challenge we've been talking about is like, what do we want to show? And then how do we want to layer it? So because the panels are not scientific visualizations per se, right? They don't have to be exactly legible the way a scientist would want to be able to look back and, know exactly what each data point is. I think we can start doing things, like layering the movement of the new asteroids we're seeing, with a different kind of time dimension of how something's changing in a bigger cycle. Like that could be mapping to color, right? That's shifting really slowly. So I'm thinking of it almost more like a musician. I think about like, what are the patterns in this amazing amount of information? And how can you pull out the kind of temporal changes, and we might be squishing them down, like to make, 6 months shorter, or maybe we're doing it all exactly in real time. But how do we pull out these kind of patterns that are something we're really good at perceiving? A layperson, right? Like we see how the clouds move past the sun. We pick up on that really fast, even subtly, or even subliminally. Like we may not even know, but we know that these things are changing around us. And so how can we use how people can perceive those things to have a really rich kind of embodied feeling about those beautiful changes and the complexity of it? We can also do really fun things like Risa was explaining to me the other night that sometimes it's likely things that have never been seen before will be detected. And so we could do something really kind of like a beacon, like all the panels could change at once and flash or something. That's really obvious, right? But we can do things across the whole piece that signal these kind of very special moments. And so that's something that's very easy to map, right? It's like a blinking light or something very exciting is happening that we want the community to know and be curious, like, hey, something just happened in that data that hasn't happened, for many months before or something. That
you make me want to camp out outside of the building just so I can wait for it.
So that would be fantastic, right? If people were looking to the whole building as kind of a lighthouse or a signal, that is signaling that. That's easier, though. I think the harder question really is how do we work with the ongoing huge amounts of information and structure it visually, structure those patterns visually in a way that's compelling and that people, again, might develop a sort of peripheral sense of, wow, those patterns feel really different today than they felt a different day.
It's really different, like a new way to communicate.
Yeah, I just think for me that part is so exciting, like that people would, maybe want to camp out or just get curious about something that they saw on a given day and want to learn more.
The Humanities Seed Grant that you got, what drew you to seek this grant? How did you use it? What possibilities and directions did this kind of open up in your collaboration?
I think, from my perspective, understanding our place in the universe is super important. And I think it's like a wonderful right of every human. And I just hope everyone has different ways of thinking about that. And it's one of the things that I love about collaborating with artists to just have different perspectives on that reach people in a new way. And we applied for this grant to be able to do this piece that we were just talking to you about. And I think, it couldn't have been more timely to really enable this collaboration right as this alert stream, like basically these events coming from the telescope are just about to start. And so we've already had some brainstorming, but the grant is going to enable us to, work with Camille's collaborator who can actually work on writing the code needed to incorporate the data into the piece. We're hoping also to work with some graduate students, undergraduate students in thinking about this creatively as the piece comes together and as we start thinking about these new sources of data.
I'll ventriloquize Charlotte, which is hard to do. I wish she could be here too, our third collaborator. She's worked a lot on open source software. Most currently, she's collaborating with the Processing Foundation, or she's their technical advisor, I believe, which is processing was a huge influence for so many artists getting interested and working computationally, algorithmically, because it created a platform that was very friendly for people and a kind of simplified way to begin accessing coding. And so I think the qualities that we were talking about that will be present in the Rubin data, because it's repeating over time, like you have a varying signal over time in different parts of the sky. And again, through these alerts also have changing, qualities of light or patterns in them. That's the kind of data that's super interesting to artists because it's just so beautiful the way things change over time, right? That can be the basis for music or animation. But I think that often the way that data is exposed is a little bit confusing to at least a starting off artist. So part of our goal working with Charlotte is to think about like how would you package those changes or the variability of different streams in a way that someone who was more interested in using them for those qualities could use them easily. But then, we don't want to lose a way to track back to what is that actual information. Or, if someone wants to understand it more, you want that to still be there and be accessible, but it needs to be, I guess, packaged is the right way, in a way that someone could more easily connect to those streams. And we haven't figured out quite yet, like, are we writing a plugin for some of these popular programs, like exactly how we're going to do that to make it, as accessible and interesting for the audience that we might imagine. But I think that's a super exciting place. Like, the idea that that data is available to anyone who wants to access it is fantastic. But if they can't actually understand and use it, isn't really available to everyone. It's available to a scientific community who knows, how to engage, or has other programmers to help them with that.
Yeah, I'm trying to imagine, as this becomes available to people, what other kinds of creative outcomes or outputs you would hope to enable, or you could imagine. You mentioned music. I think that's really interesting.
I also think that it's a real opportunity for education about the science. We think a lot about public engagement at CAIPAC, but and there's lots of ways to do that, and different ways you do it really connects with different kinds of people and people with different kinds of backgrounds. But I think there's a huge opportunity with this piece, and also with the work that Camille is describing, to think about, okay, how do we explain what we're finding in different ways, right? What kinds of objects, what's the variety? There is a ton of discovery space. There's going to be things that we know and things that we've never seen before. To me, even just thinking about how Camille and Charlotte will sort of process this stream in however it is they choose to do makes me think hard about, okay, how do we talk about what we're finding in a different way? And so I think that's actually quite exciting.
I just had a really funny memory of like going to the Science Museum in Boston where I grew up, and there's like the visualization where like the sun is a basketball and the earth is like, I can't remember, a golf ball or a baseball. And, it's like 2 rooms away. And then Mars is like, or like they use the whole museum to visualize the scale of the relationship between our planets and the sun. And it's just flabbergasting because you can't imagine those distances and the difference, the sort of levels of scale between things when someone just tells that to you. But when you see that visualization, it's like you get it in your body, and it's like you're awestruck. Like, how can we possibly be that far from different things that we can see in the sky? And that's only like our solar system, right? The scale of the cosmos that we're going to be able to see, and just the amount of information is really hard to understand. So is there a way to help young people maybe even start getting excited about, like, that's what it is to be a scientist, is to engage with that kind of complexity and quantity that they're very hard to think about even in our human brains. You need ways to abstract that. So for me, there's this kind of bigger project too, especially the climate we're in our country right now. Like, how do you get people to not feel like these kinds of problems are somehow outside their reach? Like how, like Risa said it really well, everyone should be able to engage with these. Like, we want people to feel sort of a way to have a way in, and even if they're not going to become an astrophysicist or a cosmologist, like, to respect and be excited about what that means. So I'm hoping that on Stanford campus, I think a lot of people already have that respect and are excited about what's happening in the sciences. But there's a lot of people that visit, and if this, could be a model for other places, or that, again, the tools, the open source tools we build, hopefully will be a way for other people to get excited about that.
There's really a philosophical undercurrent to the project about what it means to feel data rather than just analyze it. And so how can art and science together restore the visceral connection to information that is just too vast for us to really understand or sense directly?
I mean, let me say that, I think how we as humans think about and process the vast amounts of information that we have is one of the most important problems of our time. And, the cosmos is an example that's maybe a little bit feels more abstract to the things that we encounter in our daily lives, but actually, I think sometimes people think it's like just out there and they're not part of it, but we are part of the universe, and all of us are made of the universe. So the dynamic universe that will newly become accessible with data from the Rubin Observatory, it already shows you just how rapidly the universe is changing on different scales. But that can be very hard for people to wrap their heads around. People ask me all the time, how do you think about scales that are, the scale of 1 billion years, or, those kinds of things? And so that's one of the things that I love about different ways of seeing and feeling data. And it's what I really love about just the concept and the implementation of Camille's piece, where we really are thinking about how do we make data visceral to us? How do we feel it? How do we interact with it? How do we see its dynamism? So I think that makes us engage with it in a different way.
I also think, part of my goal with Fathom also was to remind people that humans have, most of our history, we've grappled with how do we keep track of all of these things, right? Mm-hmm. And at every moment, I'm pretty sure people felt overwhelmed by the amount of data that the folks kind of at the vanguard of that were trying to collect. So one of the panels is looking at what are sometimes referred to as heritage algorithms, or like very deep indigenous traditional ways of keeping track of information, which is something called a quipu from the Incan Empire, of all these knots. And so they were using knots in cords in a very sophisticated encoding way to keep track of literally all the sheep and all the people and the potatoes in this vast empire, right? So I can imagine those folks being like, this is an overwhelming amount of information too, when most people couldn't write, there wasn't a written, language. That this was a way of keeping track in these knots, right? Mm-hmm. And so part of what is exciting to me too is kind of pulling what's happening now at this moment is so extraordinary for us, but at some point it's gonna also look like, back, hopefully, if we survive that long, right? People will look back and be, look at the huge amounts of data coming from the Rubin and how we're starting to parse it with AI, similarly to these beautiful etchings of the water levels in the Seine River, which was the first bar graph, the first time people were thinking, mm-hmm, we're going to track change over time in a systematic way and compare it. So I'm also excited about reminding folks that we're going to look antique at some point too. This, what we think is just too much to handle, is going to look, I think, again, if we don't obliterate ourselves somehow in the meantime.
Camille, I feel like this is also, the tip of the iceberg for you. There's so much research and so much data and things happening at Stanford. You just have endless material to work with. Mm-hmm. Where is this leading you?
The opportunity to fabricate the glass on the panels was so special to me. It's the second time I've done a big permanent project working with the same glass fabricator, Meyer of Munich, in Munich. And just the gorgeousness of the way they can etch or glaze or combine the color and these different surfaces. We spent a lot of time prototyping because I really wanted the richness of the sunlight coming through the colors, but mm-hmm, also a surface that could catch the projected light. And I was really interested in the texture of that. And I think we mm-hmm, get so used to looking at our flat screens, we forget how rich texture is. So I've been also experimenting with printmaking, traditional printmaking in a press, where you squish the ink into a piece of paper and it gets embossed by that pressure mm-hmm, from the press. And I'm trying to think about how do I use sort of more computation or computer generated imagery that I'm bringing through or back into these much more historic processes to take advantage of that physicality of those processes, like the glass or the printmaking pressure of the press and everything. So I'm really hoping that I can kind of find, or that the question I'm interested there in is does the way we engage with data and computational things have to be so impoverished? Sensually, right? Like, can we bring back some of these qualities that were in other media, like into our digital media as well, or create a relationship, a conversation there that, some artists are doing it in a lot of interesting ways, but I think that's a space I'm more and more interested in, somewhat from having the opportunity of working with that glass. And just thinking, I mean, if you've seen Risa 3D visualizations in the 3D glasses, right, there's this incredible sense of depth and how they're moving, but they're kind of immaterial. But when you see the sunlight illuminating like the purple and the yellow and like all the textures, it's the same set of data, just translated differently. It feels really different. I don't know, it feels like a jewel to me, or like you really see like the kind of the connection of that data to other kinds of patterns, which you can see in the 3D, but it feels different. I don't know. I should think more about how to characterize that. But I think there's so much more potential in not thinking of like high tech things or data as this kind of not connected to our physical world.
I just want to amplify that. I mean, for me, I've worked on these kind of, so the thing that's etched into the glass is from a movie that describes, the evolution of matter in the universe. And most of the matter is dark matter. Doesn't emit or absorb light. And so it feels very like not tangible to many people. And I think it's really wonderful the way the glass and the way the etching and the painting that Camille has done there just gives it, I agree, like it's a completely different feel. And it makes it feel, just very visceral and special. And it's very beautiful with the sunlight and the light and the, different times of day. And then just to say one more thing about sort of the educational piece and sort of how we think about it. I'm actually teaching a graduate seminar on engaging graduate students with Rubin data in the spring. And I'm actually excited to have them, just think as a small side project in the class. It's going to be more of a technical class, but to have them be thinking about the kinds of data and thinking with Camille and I about, the whatever objects they might be interested in, what would be ways they could explain that. I think it's one of the wonderful things about this particular survey is the science breadth. And so it's a way to, get even, expert learners to think about how they explain concepts, how they think about concepts, how they learn new concepts. So I think it's really exciting.
I do too, especially that both of you are bringing this kind of work and approach into your classrooms. If a student or colleague came to you and wanted to start an art science collaboration, is there any kind of practical advice that you would give them?
I think just think a little bit outside the box. I think, scientists sometimes tend to get a little bit in their own worlds, and it's wonderful. I think it's just actually so fun to be able to think about your own work in different contexts and bring different perspectives in. So I think that's just great.
And I think it's like also about just enjoying a human relationship, right? Like pick someone you want to get to know better or spend time with, right? Because I think the quality of the conversations Risa and I have been having is also because of our friendship, right? So it's like that, and it's increasing that, right? Like having a reason to get together and talk about these things is really fun. And we learn, about how we look at things differently. But, Risa has asked me such interesting questions that have helped me kind of refine like what are the key questions I'm looking at in my art, which is maybe her perspective as a scientist, like writing a paper that has like a key point. I'm like, oh, I should think about that, right? So finding someone you enjoy spending time with and thinking about how that pushes your work or a collaboration, but also like just connections in the world. I think we talk again about in this country, like there's so many us versus them, and that's true in academia as well, like the humanities versus the sciences. So the more kind of one-on-one ways we can challenge that or enjoy those differences in a really interesting communication, not seeing it as a us or them, that's just so important for how we move ahead, as well as our pleasure in the world, I think.
Yeah, I mean, I think it's one of the deep joys of being at a university that has such breadth of expertise that, you can find people who are just brilliant in completely different ways. And I completely agree that, using relationships as a way to explore that is fantastic.
Well, thank you both so much for spending this time with me. And if anyone listening hasn't been to the CoDa building yet, get over there. See it in the daytime and see it at night.